Hey guys, welcome to my channel. I'm JeanTheCoder. If you guys are new to my channel, I pretty much do LeetCode style questions and I explain things in the simplest way possible. So today we have a pretty good problem, guys. So let's get into a problem statement, right? So it says given an array nums of n integers, right? Are there elements a, b, and c in nums such that a plus b plus c equals 0, right? It says find all unique triplets in the array which gives a sum of 0, right? Okay. Notice that the solution set must not contain duplicate triplets, right? So pretty much you say all the combinations of triplets that we generate, make sure that they're all unique, right? So this is a very important aspect. So so this problem is kind of very similar to the two-sum, right? Especially the two-sum when the array is already sorted, right? So let's see how we can approach this problem. So we pretty much know we're given this array, right? And then we're given, so now they want us to return all possible triplets, right? Right, that we can get that makes the sum when you add up all the numbers together, right? They add up to 0, right? So that's kind of what we're trying to accomplish now. So you guys can see, right, on the array, the solution that they found -1, -1, 2, right? Because -1 plus -1, all right, that's -2 plus 2 is 0, right? Just like this one, -1 plus 0 is -1, -1 plus 1, that gives us 0, right? So pretty much, by all combinations of numbers that we can get, that makes the sum equals to 0, okay? So now, guys, the most obvious way of going about this problem, right, would be to generate, all possible triplets, right? And then from there, right, when we generate all possible triplets, we're going to try to find if they're equal to 0. So if we find any triplets that are equal to 0, right, we add them to the output list and we return that, right? You know what I'm saying? So that this will be the easiest way of going about this, right? So let me just show you guys, right? So this approach that I'm talking about, right? So pretty much it will be 3 pointers, right? 3 for loops, right? So one that starts at I, that's going to iterate through the array, right? Simple linear loop. And we are going to have another linear loop, right? That's going to check all the numbers starting at I plus 1, right? To check all the remainder array, right? And then another one that's called K that starts at J plus 1, right? That checks the remainder of the array as well. So you guys see how much work that we're doing. This is an n cube solution, guys. So this thing would pretty much generate all possible triplets. You know what I'm saying? So it would be -1, 0, 1, -1, 0, 2, -1, 0, -1, -1, 0, -4, right? All possible. And then after we don't find a solution, we keep going again. 0, 1, 2, 0, 1, -1. See, this is so much work. We're doing the same thing over and over again, right? Checking all the numbers over and over again. There's a better way of going about this, right? So the way we're gonna go about solving this problem, guys, is gonna be similar to the way that we solved the two-sum when the arrays are already sorted, right? It's gonna be very similar in terms of we can pretty much we can afford to sort the array, right? We can afford to because the solution right now is n cube, right? And we want to reduce down the time complexity to something better, right? So if we sort the array, right, this can be very beneficial in terms of we could do a lot of stuff with it, right? So what can we do with it, right? We can do, so after we sort the array, right, we're gonna apply a two-pointer technique, guys. The same way we did the two-sum when the arrays were sorted. So if you guys haven't seen that problem yet, I'm probably put the a pop-up somewhere so you guys can click on it and go watch it, right? Because I've went into a lot of detail in that when I did that problem, explained the two-pointer technique. So this is where I introduce you guys to that two-pointer technique. So yeah, so the way we're gonna go about it, right? So for every I, right? So we're gonna iterate through the array, right? And then we're gonna use a two-pointer technique, right? That's gonna search the remaining numbers in the array for a pair that's gonna help me make the sum equal to 0, right? So pretty much, let's say we have I, right? I. So we're gonna search the remainder of the array, right, for two numbers that equals to that's gonna help me. That can, when you add those two numbers that you're gonna find in the remainder of the array, right, plus myself, we add them up together, that gives you a 0, right? So to be able to afford that, we need to sort the array. So that's why we're going to sort the array. Sorting the array is going to cost us n log n, right? Which is still pretty good than n cubed, right? And then still pretty, much better than n squared as well. So we're going to sort the array, right? After we sort the array, guys, we're going to utilize the two-pointer technique for every iteration. So the time complexity then will make it an n squared solution, guys, which is better than an n cubed. So let me sort the array real quick, and yeah, let's see how we do it. Now that the array is sorted now, guys, you know, we have a -4, -1, 0, 1, and 2, right? So now that they're sorted, right? So pretty much how the algorithm is going to work, we're going for every I, right? For every the index that we're at, right? We're going to search the remainder of the array using left and right pointer to find a pair of numbers, right? When you add them up together, plus myself, right? The number that's being pointed out I, right? That gives you a sum of 0. So we're going to check every combination of them to make sure that they're 0, right? But we're going to be very efficient about it by using the two-pointer technique, right? So the I is going to iterate through the array, cost us n, O of n, right? And then the left and the right pointer for every I is going to cost us O of n, right? So the time complexity is going to be n squared, guys, you know? So now that we went over the thought process, guys, let's try to implement the code, right? So first things first, right, we're going to sort the array. Like I promised you guys, arrays that sort, right, by using the built-in function, right? So we sort the array, nums. After we sort the array, right, now we need to build the output list, right? Because they want a list of lists, right? So that's why we're doing it like that, right? So now that we have that, so we got res new array list, right? So we build the lists, right? So now that we did that, now we need to have the for loop, right? To iterate through the array, right? So we got and I is less than 0, right? And I is less than 0, less than nums ln I plus plus, right? So now we're gonna do a simple check, right? For duplicates, right? So if I is greater than 0, right? And the number, right, is equal to the number that we're just at, right? I minus 1, right? So we do that, guys. So we're gonna, if it's equal, right, we're gonna skip it so we can continue. So pretty much continue tell us, hey, all right, to skip that iteration, right, to go on to the next iteration. So this pretty much makes sure that we skip the duplicate, right? Because it says all the combination of stuff needs to be unique, right? So this is why we do the skip. All right, so after we do that, guys, we're pretty much, you know, in good shape. So now int left is equal to it's gonna start I plus 1, right? Wherever I is at, plus 1 of it, right? And then the right pointer is gonna start at the last element in the array, so plus 1, right? And then we keep doing while the left pointer is less than the right. This is the same thing I did in the other problem, guys. So it's very, very good. So left and the right. We're gonna check, right? Does this int sum? We add all the sum together, right? Nums of I, right? Plus whatever number left or the right is pointing at, right? Whatever they're pointing at, their sum, right? So we're gonna check their sum together, right? If the sum, we add them up together. If the sum equals to 0, right? If it's equal to the target that we're looking for, because the target now, guys, I told you, is 0. So this is why we do that. So now, once we found a solution, right, we need to put them in a temporary list, right? So we could add it to the output array, because the output array holds a list of lists, right? So this is why we're doing that, guys. So TMP new array list, right? All right, so now that we did that, we need to add all the numbers that are matched, right? So we need to add nums of I, right? That's part of the triplet, right? If it was good, TMP that add nums of left, right? Wherever left's pointing at. All right, so now in the lastly, right, we need to add the number that's being it's at the right side as well, right? So now after we did that, right? So we've used all the numbers, so we need to add them to we need to add the temporary list to the output list that we're building, right? See, this is the output. This is the output list, res, right? So we do res that add the TMP, right? That's gonna hold the output list. All right. So now that we did that, right? Now we're gonna increment the left pointer to go on to the next number, right? So we increment the left pointer to go on to the next number, right? So now we also need to decrement the right pointer as well, right? Because we just used the number that was being pointing at by the right? So after we do that, guys, there's a very important step that we're gonna do, right? We need to skip any duplicate, right? So we're gonna skip duplicate by left is less than the right, and the number that was at the left side, right? The number that we're currently on is equal to the number that we were just at just now, right? If they are equal, then we need to keep going on to the next number because we don't want to try the same numbers again, right? I'm gonna show you guys a quick example real quick. So let me just finish, do the same logic for the right pointer, right? All right, so with the left is less than the right, and nums of right equals to nums of right plus 1, right? Because that's the number that was to its right. So we decremented right, then we check the number that's to my right. Hey, are we the same thing? If we are, right, I'm gonna keep decrementing myself until we're not the same, right? So, all right. So yeah, I'm show you guys an example of that real quick, right? So yeah. So pretty much now I have a example for you guys, right? Let's say we had -1, so I changed those numbers, right? It's -1 and 2. So now let's say we had a combination, right? So we got -1, right? That's -2 plus 2 gives you 0, so right? So we found a pair, right? So we will add that to the output array, right? So output array. So the output array will hold those two numbers, right? It will be -1, -1, and 2, right? The numbers being pointed by the left pointer and the right pointer, right? So we add them to the output array. So now after we do that, right, we need to increment the left pointer, right, to go on to this number now. So yeah, before we even decrement the right pointer, right, we're gonna see that -1, and 2, that's the same combination. So that's why we have to skip until we find a number that's not equal to the previous number, right? So left was pointing at -1, right? And when you increment the left pointer, it's still pointing at -1, and that's the same combination, guys. We don't want the same combination. We want the unique combination. So that's the whole point, the whole reason why I'm doing the whole skipping duplicate, right? So that's why I'm doing this here, guys, right? You could apply the same logic to the right, right? Let's say the right was, right was there, right? It would be -1, -1, 2. It will be the same number, so we need to skip it. So that's why we do the whole skipping, guys. So yeah, hopefully I clear any doubt, right? So now, guys, the next step, right? So after we check, so let's say we didn't find a sum, right? So if we didn't find a sum, we now gotta enter this if statement, right? So now we need to do an else if statement, right? That's gonna check if a particular number, right? So if the sum, right, when you add all the numbers together, right, the number I left and right, if the sum is less than 0, right? If the sum is less than 0, then we know we need to the sum is less than 0, we need to increment the left pointer, right? Because the sum is too small, we need a bigger number, so we gotta increment the left pointer, right? And then, guys, if the sum's too big, right, then we decrement the right pointer, right? We already check if the sum is equal to 0 or equal to the target, so we don't need to, you know what I'm saying? So that's the whole algorithm, guys. It's very, very, very good, to utilize a two-pointer technique to help us efficiently reduce the time complexity from an n cubed to an n squared, guys. Very, very good, guys. So now after we do all of this hard work, right now we're just gonna return the output array, right? That we built, right? So we do return res, right? So I think everything's good. So let's try now press run, right? All right, so it seems like we passed that small test case. Let's check all the test cases. Perfect, guys. We passed all the test cases, Yeah, guys, let me know if I did a pretty good job at explaining this problem, guys. Let me know in the comment section. Let me know any videos you guys want me to do, any questions, anything at all. I want to thank you guys for taking the time to watch this video. If you guys are new here, make sure to subscribe because I do a lot of videos like this one. And yeah, thank you guys for watching, and I'll see you guys in the next one.